Welcome. Alright, this is our Peercoin analytics. So we've got PA online and script online that we made yesterday, and a backup just in case, though that probably isn't necessary. So where we last left off, right, we were working on querying the internet to using Blockbook, right? So we switched from Chainz to Blockbook, and we were looking for how to best implement Peercoin analytics. So one of the things that I was hoping we could do is talk about why. So when you get involved in something in crypto, one of the things you should ask yourself is this a moral thing to do? If the answer is no, then you're probably in a scam. So, is this a moral thing to do? So, originally, what was the idea of Peercoin analytics, right? We were analyzing our own transaction history that we pulled out of our wallet, and we were looking at it for our own history of activity. That seems perfectly moral to me, right? You just give more knowledge to people about their own goings-on. So it was kind of a record-keeping, an organizational tool, right? So now we're querying external databases to ask them about things. Now, those databases tend to just be compiled versions of the blockchain. The blockchain is a publicly accessible resource. So I am merely cultivating information that other people have cultivated from a public stream of information. So it becomes a little bit more derivative. So the question, is this moral, becomes a deeper question. So let's look at kind of how you might use this, right? So standard way to use this, a standard way that someone might be interested in using this. Go on to a block explorer, see the top wallet addresses, right, and analyze their history. It's not my favorite use. I think it's definitely a use case. The morality of doing that, well, you know, it comes down to the question of whether or not cryptocurrency itself is moral, right? Is it okay that everyone's transactions are public? And my response is that as long as names aren't associated, I think it is. And the reason why, not all money is anonymous, public, or pseudo-anonymous. It can be any combination of those. The concept of money is rather abstract, and it can come in shapes and forms when you start talking about what people know about it, about the knowledge of money, right? So in blockchains, you have this particular situation where you need it to be fully auditable by anyone in the world at any time, so that everyone can be convinced that the other people aren't cheating, and ultimately you can verify yourself, right? So that's how decentralization is built. It's built off of this ability to trust no one but yourself, right? No one but yourself in math. And so they hand you this puzzle, and you take it apart mathematically, and you say, this is how it must be, according to the rules that we have defined as logic, right? And so there's concepts of objectivity and subjectivity and all of these very abstract things. But let's focus back on the concept of anonymity, pseudo-anonymity, and public, right? So this is pseudo-anonymous information, and I think that's really where it's moral, is because it's pseudo-anonymous. If this were, you know, I said, hey, give me the name of a top rich person in the world and I will analyze their bank account history for you, that would sound eesh. Arguably, the only reason why that sounds eesh is because of global capitalism, right? And the way that we defend our richest, but it's beside the point. We need to focus on information because that's what the blockchain is. And once we abstract that, then money is information, right? So it's all information. So saying whether or not information is moral, whether or not it's moral to know something or to learn something, we have these ideals where we want that to always be good. But I think in reality there are things that you shouldn't know, things about privacy, right? And that's cryptography, right? The other end of the spectrum is that cryptographically you have a right to privacy. You have a functional ability to defend your own privacy, and therefore, in my opinion, a right because of what privacy is. Not that you have a right to anything that's possible, but so as long as it is simply entering a Peercoin address and then analyzing its public transaction history, I believe that it is moral, even if you're using it on other people's addresses, because it's still just an organizational tool. And I'm also not going one deeper. See, okay, in order to really analyze a network of cryptography, and in order to really glean the information that you might think someone might want, it must be associated with the real world somewhere. Otherwise, it's just numbers floating around, and you can make some really, really interesting, intricate webs of where currency flows on a blockchain network abstractly. But really, the key is having things like exchanges that pin that web down to concrete activity in the real world. So as long as I'm not doing that, as long as I'm not identifying things as exchanges, going multiple layers deep, right? All I'm doing is taking one address, finding all of its transactions, and then analyzing those transactions. Speaking of which, let's go to the code. So, we have the ability to go open an HTTP request. We learned how to sleep. We are going to be able to loop over transactions and pull out their JSONs, right? We do some funny things with the buttons, and we go to a target address, right? We pull out a target address, we go to Blockbook, we pull out its JSON, and then we go feed it into the transactions, and then the transactions process the data at that address, right? So now we come down to process the data, right? So this is a plotter. This is from the old code. So we go to process the data, and we start pulling things out of the JSON that we formed, right? So this is a global transaction. JSON is a global that we made. We actually aren't using raw data anymore. So basically transaction JSON is our raw data now. And so we pull that out, and we start pushing things into arrays. So we form a transaction ID array and an index ID array, right? And so the reason for these is to kind of, there's multiple JSON elements that refer to the same event. And the reason for that is because if an address is listed as both inputs and outputs, or multiple outputs or multiple inputs, it will create a unique JSON event for each one. And they're all the same. They're all the same JSON event. So again, ideally I would put this before the loop, but that's for future problems, because there are other issues with this that I'll get into in a minute. But so then we start pushing amounts, right? So we push the date. Now we're kind of gonna start forming our res data, right? And so we're gonna push a date, Then we're going to try to figure out this amount. And basically, we're going to take apart the entire transaction. So we've got the JSON for the transaction. So we're going to count up the outputs and subtract off the inputs and push that as an amount. We're also going to figure out whether it's mint by stake or send receive based off of whether or not there are fees. This is not the best thing in the world because a coin stake can actually consume fees, but rare. So rare. I mean, there are questions about multisig, but this already broke multisig back here when I started talking about individual addresses anyway, like basically at the beginning. So, and then a subtag, which I haven't dealt with yet. This, I'm not even sure I'm going to do that, but I wanted it so that I could just kind of shove this into the rest of the code, right? The only thing I changed from here on out is I added the subtag, all right, subtag here. And then everything else basically just the way that it used to be. So that's nice. Now, why doesn't it work, right? So the thing that's not working right now that I think would really push us forward is the date. And the reason why I think the date is an issue, and I think we should just go right to where we begin the date. Right, so we're going to push a date here, right? Well, all we're going to do is we're going to multiply this by 1,000. I think that it was in seconds instead of milliseconds. So we import the data. Now it counts through the transactions. Oh, I need to remove that. It says that it's processed and graphed. Indeed, good graphing. Process the data window. Look at that, annualized interest. They started here, they've got some annualized interest. Their balance, the percentage of their balance that they minted, 1%, right? Here, they minted twice. This is how long it took them to mint. So good stuff. Basically, we're done. Ta-da! I know you thought it would take longer. So let's pick any any address, right? So pop on here, right? Go to some block recently. See, yeah, but minters, and this is where we'll start to get into a problem. But great, this person has under 1,000 transactions. This is going to take forever, but I want to show you what it does. So let's go back to here, pop in the address. Actually, let's reload. All right, so when we start up, there's some funny things happening with the buttons, but basically click the red button, right? So put in your Peercoin address, click the red button. It says, oh, hey, there are 968 transactions here. Each transaction requires an API call, right? Because I need to ask for the transaction. So I load in the address, and I find out, hey, there are 968 transactions at this address. This is not uncommon. This is very common for proof of stake. Most of these transactions are mint transactions. The whole point of this is to analyze minters. I need to be able to handle very large numbers of transactions. But every single number here is a call to Blockbook asking them for a new piece of information. So I am asking them for pieces of information all the time, only during loading, right? But it's a lot of information. I would love to figure out how to package this, or send them one call that asked for all of it at the same time, because it's not that much information. I looked at it; it's like megabytes of information. It's really not that much. But each time I have to think about it and then go ask a question and then get an answer and then bring it back home and then go ask go form a new one, right? So that's not great. Anyway, the other issue is that it doesn't go over 1,000. which is a serious issue because, again, a lot of minters, we're talking 10,000 transactions. Now, the good part is the button's turned off while it's waiting. Now, this button isn't. I don't actually know what happens. I'm not going to press it. But the button's turned off. So it knows that it needs to think. This is kind of, kitschy and still early days, but essentially it functions. You can't get infinite transactions. You can't even get over 1,000 transactions. The reason why 1,000, at 1,000, the address API call stops giving me transactions. So it maxes out at 1,000, and then it won't give me any older transactions. So the API won't even hand me more than 1,000. Just transaction IDs. I'm not even talking about the full JSON object. I'm just saying I can't get it to even tell me more than 1,000 transactions for an address. And so I'm not sure how to even find out about those transactions via an API call. So that's an issue. Chainz, I think, was able to handle that, whereas Blockbook is not. But Chainz wanted a different thing where they wanted a key, right? They wanted an API key, and that's kind of annoying. So this is what we got. Oh yeah, I forgot about that. I need to turn that off. But anyway, processed and graphed. So this random address that I just looked at, this is their address history. Right, kind of scary, right? So now I know everything that they've done since 2013. Sorry, it's kind of funny. And then I just click this, and it processed it. And now I know how much interest they've been making. As you can see, here's the 4 to 5% number that I keep talking. I say 5% because, I mean, that's stretching it, but really it's like 4% these days. I mean, the trick is that the difficulty doubled. The proof of stake difficulty went up a lot since version 0.9, so that's kind of changed things. So you don't really get 5% anymore, you get 4%. But still, you can see here, right? So version 0.9, that was back here, right? This person looks like they stopped minting and then they started minting again at version 0.9, which is kind of interesting. They may have gotten a burst out of that. Actually, interesting. This is an interesting person. I wonder if they turned off their minter in preparation. When was version 0.9? Right, so it kind of becomes like you can start to actually see what people were thinking at different points in time. All right, so version 0.9, June 2020. Okay, so there's no way. They did not have that kind of information. But you see here, ooh, this is actually a really interesting one. Okay, so June 2020, right here. This point is where version 0.9 released. That's why this went up so much here. So this spike up, this is continuous minting and then version 0.9. I want to talk about this spike though. So this spike is a direct response to this flatness. What happened was they stopped minting and then they started minting again. And they stopped minting for about a year. Yeah, like 10 months. So they stopped minting for like 10 months, and they started minting again, and they got all of their rewards that they would have gotten in this year. They got it over here, right? Which is why it went, so 1% is what the reward used to be, and it was stochastic. So you had some above and some below. And then, I mean, there was also this that happened, right? So this person sent some, so it like changed the ratio a lot. That's why there's that discontinuity is this jump here. Oh, that's just time passing between events. But anyway, the point is that they stopped minting for a while, and then they started minting again, and they got double the interest. You can't do this anymore. We fixed this. So at version 0.9, after a year, your stuff starts expiring. So if they were to do this again, and we used the maximum coin age but not the like reward increase, what would have happened here is this would have gone down, it would have been flat, and then it would have come back up at around, a little bit over, but around 1% over here. So this wouldn't have spiked up above 2%. So in my opinion, that's correct, because looking at this, it looks like they just turned off their minter for a while and then got all their rewards later anyway. That said, this is totally a continuous minter, right? I say that. Yeah, you were a continuous minter, right? Their annualized interest was high, right? This number, the way that it calculates continuous minter is really interesting. Here, check it. So, calculate interest, right? So this is calculating the numbers, but POS, yeah, the POS reward. Here we go. Continuous minting, right? Setting the bar for continuous minting. So what we do is we say, if you're before the switch date, the version 0.9, right, 2020, 06, 05, then your bar for continuous minting is 75%, right? So back here, right? So here they were continuous minting, but then over here they kind of stopped continuous minting, right? And then down here, right, so 79% of 5. The choice of using 5 here, arguable. This number isn't really right. But anyway, so I basically say 75% of 5, right? So if you're above 3.75, which they clearly are here, then they're a continuous minter. Anyway, so you see their balance, right? So the percentage of their balance, I mean, they were doing good off of 5 years of the 1% proof of stake. They were starting to build a percentage of their balance. Not a whole lot though, 2-3%. In just the year since version 0.9, right? They've grown by 10%. So their wallet balance has grown a good bit. Or sorry, just in the 2 years? Yeah, I guess I'm saying in 2 years, 10%, 5% per year, stuff like that, right? So this is the reward of their mint events. I like this one because it usually shows this kind of like fall as they start to split. So this is about trying to see the splitting. Yeah, this graph just really clearly shows when you waited a long time between a thing. But I mean, that was already kind of obvious. I don't really like this plot. I'd really rather replace it with something like a Fourier transform type thing, and I know I keep talking about that, and it doesn't really make any sense, but I want frequency. I want the x-axis to be frequency. Well, I guess the y-axis could be frequency, but I want one of the axes to be frequency, but I'm not exactly sure what I want that to look like, or why, or how. So we aren't doing that now. Anyway, so that's it, right? That's the whole thing. So now this random person's fucking address, I've gone through and I've learned all sorts of things about them. I've learned about that they're a continuous minter. I've learned, hey, they sent some away in this early days, but since then they've basically been minting. I know, hey, look, this is their interest. And I don't necessarily know if this is part of a bigger wallet, which it probably is. I don't necessarily know anything about this person. I don't necessarily know anything about their IP address or any of that stuff, right? All I know is, was this person who is minting blocks for the network, is this a person who mints blocks for the network often? Or, what's their deal? And where did they get, how long ago did they get their coins, right? So that's kind of how I see this. Anyway, so that's fixed. That's done. All done. So next thing that we want to do. So we could push this. This would be ready for a push. I am basically done with it. I mean, there are a lot of little things to fix, but I'm not going to spend my time on that right now. So, because I think it's functional, right? If something's functional. Alright, so now we want to analyze Chainz stuff again. And I know that we got rid of Chainz, but we want to bring it back. But we want to bring it back in the right way. So instead of trying to do API calls with Chainz, we're gonna use this button here, right? It's gonna download the transaction history as a CSV. See, this guy's got more than 1,000 transactions. So if I retuned it to do API calls, all those things, right? Okay, well, I guess with Chainz it wouldn't be so big a deal, but it would take forever, right? So instead of that, let's just download their CSV. Okay, so CSVs, what even are they? About that, right? So it looks like this. You got your, whatever this is, you got your header, and then you got a transaction ID, you got a block. So both of those aren't really going to be useful to me. You got a date, that's useful. Type, that's useful. Amount, that's useful. And you have a total. Right. Okay, and so basically what we're going to do is we're going to try to analyze this. We're going to try to feed it back into all of my stuff. Okay, back to the code. So we want to make a new one. Let's make a new one. Let's start back from this guy. Right. And we'll call it PA Chainz. Oh, I do want to, before we get too deep into this, I do want to change online to not reference Chainz, but instead reference powered by and I'm going to put that in here too. Okay. And we're also going to copy at the end of the day, this is not how we want to build this. We want to kind of separate these out. We want to have the online one be run from a browser, run from a server instead of locally. We want the Chainz and the not Chainz to be combined into one that can like figure out which one is which. But not what I'm doing right now. PA Chainz. Alright, so let's give some quick instructions, but it's going to be the exact same thing. Analyze a transaction history, export a transaction history from Chainz. I'm not going to have enough space for this. Oh, right. Of course I don't have enough space for it. I didn't have enough space for it before either. And that's it. So that's done. Let's just make sure that was it PA Chainz, right? So PA Chainz. Right, now we're selecting files. Can you see that? When we select this file, export transaction history from here, click red button. So we selected a file, now we want to import. Yeah, it failed. Of course it failed. It doesn't have the right conversions, right? So it's built off of the Peercoin one instead of Chainz. So how does it work here? Well, first we take the input on Chainz. This is all working. That's all great. Here, we're reading it. We drop it into proc data. We switch the colors, right? All good. So yeah, so then it calls proc data. It says, okay, when it's done loading this in, go call proc data, which is funny because that's kind of what I ended up doing in the last one too, but I had a wait loop instead. I was debating with similar things. We're gonna once again go ahead and get rid of this because I don't like this here anymore. We're gonna leave it in the original one. It's a better way to plot or something. I don't know, there's some legacy stuff already. So proc data, right? Target address. I don't even know, man. I don't even know. But I got this raw data, right? So raw data is a global. The raw data came here where I read it, right here. So the raw data is the result of the reader. So here I'm now going to try to split up my raw data into rows, but why don't we go ahead and take a look at it. That's the cool part about CSV. JSON is like these objects, but with CSV I can just look at it. So yeah, looking good, looking good. Alright, so that's the raw data. So now let's look at it after it has split. Alright, so it basically looks the same, but there actually is a key difference here, I think. Oh, maybe there's not. You know what? I don't even know that that's a problem. I'm going to try... So yeah, so we need to do that. Let's see if that's it. Not sure what that comment is about. Oh, it does. Okay. Cool. All right. And basically, we just need to sprint through this, and then we're done. So let's take a look at this row. Alright, so the first thing it says is this stuff. then it starts saying the real transactions. So let's kill that first row by saying I equals 2. Oh, it kills the first 2 rows. Good. Good, 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 good. And if I is less than, it should be len. I'm not sure why it was len minus 1. That may have been wrong in the other one. Or what is I? Should I get rid of I somehow? Yeah, I never initialize I. Oh, I do. Yeah, it's right there. Duh. I don't know. I don't know. Alright, so date. Date is the third entry, which means something. So let's look at dated. There you go. Not a number. Not a number, not a number. Alright. Alright. I'm fairly certain it's gonna spit out like a real date as opposed to a fun number date. No. It spat out nothing. Why did it spit out nothing? Because it hasn't parsed it. It's not quote quote. It's just quote, right? Because the wallet does weird things. Alright, try that. Alright, so now this row is a bunch of individual things. And now dated is a date. Excellent. So we can remove these. Alright, but we know the rest of this won't work. So we know that the next one goes transaction block, date, type, amount. So we want this to be 4. Okay, that's good. The tag is 4. And then address is nothing. So address I guess I'm going to shove the transaction into the address. No, but it should be 0. Right, because I want to call it transaction. Yeah. I mean, if I just call this adder. Okay, so the question is, do I rip out this? And I think I have to, otherwise it's just confusing. I would love to leave it in just in case, you know, in the future I figure it out, but I think it's just confusing with it there right now. Which means we are basically going to rip out. Oh, also, what are your timestamps like? Oh, you're pulling them out of. Yeah, okay, so the timestamps are fine. I don't have the same problem that I had with the last one. So what else do I need? This whole section. Oh, I'm gonna regret that someday. But not today. No. Maybe today. Alright, so I broke it. So how much did I break it? So it still does this, and that still happens, but it doesn't actually, like, put it in. I'm guessing I left a function open. I'm guessing it's in here somewhere. This is proc data. I made too many changes. That was it. So wasn't it able to make it all the way through because transaction doesn't exist? Right, this was the part that I skipped. Activating the right JS file. Alright. Time to test again. Oh. Ta-da. Okay, so that worked. Takes a while. And is wrong. Oh, I know why it's wrong. It's wrong because of this. In this file, they just call it, they call it stake. Now try it. Yeah, it'd be nice to have that happen faster, or at least warn you. But ooh, wow, this person got a high percentage. Not sure why they got such a high percentage, but they have been minting since 2018. Oh, this is wrong. No, it's wrong. Alright, but I believe this. I believe this. See, they were getting really high previously, too, though. They must... they did something. Not exactly sure how they are minting so well. But they're doing really good. They're really good at it. It's only a little bit better, but They're a good mentor. How do I fix this? So, what's the issue? Oh, here's the issue. Is that it? Yeah, I'm fairly certain that's it. So again, I pulled this data off of Chainz, right? Oh, come on. See, if you don't do it right, it fucks up. Do it slowly, take it easy, import the data, wait, let it process, then do this, and then wait a really long time for your computer to lag out. And then you will see. See that? I love that. That like tail. This is the splitting period, right? So by looking at something like this, you can see like where the splits happen. Kind of a similar thing here, right? So these two are often related. You can very clearly see in an address like this the minimum of version 0.9, right, where the minimum mint reward jumped up. You can easily see that the elbow, right, this elbow is as clear as day. And this is the only chart that has no difference, because the time between mint events is completely independent. That's why I really want something here, is because this is the only one that actually has years of data. This has, 5 years of data built up. All the rest of these all changed, and so you're looking at the change, but they don't have, like what's going on here is very hard to see. We need many more years of data to really tell what's going to happen here. Yeah, so all done. Basically, that's the end. Okay, so let's go ahead and run the online one more time. Oh, also, I do want to come back to that. I want to say, I want to rip out the entire address part. I don't need a target address. Don't need an address warn. Probably don't even need a BR. Alright, so let's import this same address. So, this is the address, right? And boom, it can't load all of the addresses, which means it's going to be fundamentally wrong on so many levels. Actually, I'm not going to wait for this, because it's going to miss the entire beginning. It's not going to have the right total, because it doesn't count the total anywhere. Right, this only has 2, so we're going to do this one. Oh, shit. It's not that. I'd really rather one with a little bit more than 2. What does this have? Yeah, so this was the really long one. Well, fine. We can wait. We'll talk. We'll talk while we wait. You guys are all sorts of fun to talk to. Okay, so what have we done? Right? Oh my God, what have we done? So, I'm gonna leave that open. What we've done is we've created a program. Now, this program has 3 modes, represented by 3 HTML files and 3 JavaScript files. At the end of the day, of course, we'd like to do that in a bit more interesting of a way, but right now, there are 3 things it can do. It can analyze your client history. This is from the Peercoin client that's downloaded from peercoin.com. It can analyze So it can analyze three things. The client history, a Chainz export, right? I guess it's technically a client export, a Chainz export, and a block book API. So we can interface with those three things. You either give it an address or you give it your wallet, right? Because with your wallet comes identity, but it's only you, so it's okay for you to know your own identity. With everything else, you have to feed it an address rather than a wallet, because I don't want to be analyzing people's wallets. I don't want to try to figure out who is who. I just want to look at an address and say, are you a good minter or not, right? Okay, so these are the three things we can analyze. What does analyzing mean? So analyzing means that you're able to see, what does their balance look like? You know, how much have they had at this address over time? How many coins have they minted, right? And therefore, what percentage of their balance was minted? Now, going from total Peercoin minted to percentage of your balance minted is a little bit tricky, because you got to use the time dependent balance, not the end of the line balance, right? So tricky. But what we are saying there is, we're saying that, okay, if I bring in $100 and I send out $100, and in between I minted 5 coin, then at the end of the day, my Peercoin balance is 100% Peercoin minted, right? So it doesn't matter if you thought that you were sending out the minted coins. If you minted coins and at the end of the day your balance is lower than the total coins that you minted, then you're like over 100%, right? So if you send your minted balance away, then it gets weird, which is why I don't want to include that there. These are real numbers. Up here I'm trying to come up with real concrete statements. So that your average Peercoin balance over this date window, how much do you usually have in there? How many Peercoin have you minted? What is your average annualized interest in percentage? And are you a continuous or a non-continuous minter? All right, so let's process this guy. We find out their average balance, almost 13,000. They have minted 2,000 coins, right? Their average interest is about 1.6, so they've been doing stuff for a long date window. Long date window for them to have, only that interest when they've minted, 6%, 1/6 of their wallet, and they were definitely a continuous minter. And we see their charts. So that's what we've done. Oh yeah, right. And I wanted to check just one more time this guy, because I ripped a bunch of stuff out. Oh no. Wait, what? Guess I didn't save it. Weird. We don't want that. We don't want that. What is happening? Alright, PA Chainz. We'll rip out the buttons. Alright, so we've ripped out the buttons. Like I said, we've ripped out all the buttons. Let's make sure that it still works. I mean, it takes a second to process it also. So it's not like it's easy to process this many events. But there are better ways to do it than what I've been doing. But anyway, okay, so it looks fine. Let's make sure I didn't screw this up somehow. No, that'll be fine. So that's it. So right, we want to git add how did I change this? Now you get to watch me not know how to use GitHub. Right, so all we did was add in the address warn. And address warn, right? So and we will call this API and Chainz. And I'll do this offline. Alright, so that's it for today. You can easily find what we did. You just go to my GitHub. Go look for repositories, and it's this guy here, right? I guess I should probably update the README and stuff too. This is kind of a 2.1, maybe a 1.2. Maybe we'll call this a 1.2. You know, and you can see all the things, and they're going to be 3 HTMLs, and you can go into the 3 HTMLs. So you just go here and you go to code. And you go download zip. You can also do all the GitHub stuff, but you can just download a zip file and then run the HTMLs, and they'll open in your browser. Again, ideally, you know, I'll be putting this up on a website or something, but that's not what it is right now. So, thanks for watching. All right, bye.